So this is our honors chemistry lesson video for section 8.2, and this is part 1 of 4. So chapter 8 is going to be incredibly long. So the first section is pretty short, but 8.2, 8.3, and 8.4 are all going to be multiple videos. So just bear with me and we'll get through it as best we can. So like I said, this section will be in 4 different parts because Lewis dot structure has a lot of stuff you need to learn. So in 8.1 we started talking about covalent bonds where atoms share electrons, and so now we're going to continue to talk about that, and we're going to learn how to do something called Lewis dot structures. So in ionic bonding, atoms transfer electrons to achieve noble gas configuration. So you have ions, they have actual charges, and we would balance our charges to form our compound. When covalent bonding, atoms share electrons to achieve noble gas configuration. So remember, they're trying to be like a noble gas because they have a full valence shell of electrons. Most atoms share electrons until they have a total of 8 valence electrons. This, of course, is called the octet rule. However, hydrogen, because it's in the first energy level and can only hold 2 electrons, it only needs 2 electrons total to be stable like helium. So a single covalent bond is created when 2 atoms share 1 pair of electrons. So 1 pair is, of course, 2 electrons. A dash represents a bond which is made of 2 electrons. An unshared pair of electrons, or sometimes called a lone pair, is represented as dots. Okay, so a bond is drawn as a dash, and a lone pair are drawn as dots. I am super picky about this, so again, if you're not in my class, you may want to check with your teacher. Some people will draw the bond as 2 dots in between the elements. I do not count that. Okay, if it's a bonded pair of electrons, it needs to be drawn as a dash. If it is a lone pair of electrons, then you draw it as dots. So it says, given the Lewis symbols for the elements nitrogen and fluorine, predict the stable binary compound, which is a compound composed of 2 elements, formed when nitrogen reacts with fluorine, and draw its Lewis structure. So we know that nitrogen has 5 valence electrons. And we know that fluorine has 7 valence electrons. So fluorine only needs 1 more valence electron to be stable. Nitrogen needs 3 more. So what will happen is when fluorine comes to nitrogen, they will share a pair of electrons. So see, what they're going to do is they're going to share these, and so this would then become a bond, which I'll draw over here in a second. So now fluorine is stable, because see, it has 2, 4, 6, 8. But nitrogen is still not. It has 2, 4, 5, 6. So another fluorine atom will come around, and they'll share a pair of electrons. So see, now fluorine's stable, 2, 4, 6, 8. Nitrogen's still not there, 2, 4, 6, 7. So it needs another fluorine atom. So instead of crossing charges to figure out how many fluorines in a Lewis dot structure, we would need to figure out how many times it needs to share electrons. So not quite as quick of a process. So again, fluorine has 7, and so they would share these 2. And so this is what it would end up looking like. So its formula would end up being NF3, because there's 1 N, 3 Fs. All right, and then to draw the actual Lewis dot structure, see, nitrogen has a lone pair on top, but these are all bonds. So I'm going to draw them as dashes, not as dots. And then if you look, each of our fluorines have 3 lone pairs around it. So I would do my 3 lone pairs, my 3 lone pairs, and my 3 lone pairs. So this is what the Lewis dot structure will look like. So I'm going to show you how to draw these without having to go through this long process. Okay, and so if you start with the formula, you don't have to do all of this matching and figuring out who needs to share what. So we'll get to that in just a minute though, because I'll show you the rules for writing those. So the next one, it says compare the Lewis symbol for neon with the Lewis structure for methane, which is CH4. In what important way are the electron arrangements about neon and carbon alike? And in what important respect are they different? Okay, well, if you look, neon is surrounded by 2, 4, 6, 8 electrons. Carbon, remember, a bond is 2 electrons. carbon is surrounded by 2, 4, 6, 8 electrons. Okay, so we can say that they're alike in that both elements have a full octet. Okay, so they both are stable and have 8 valence electrons. But what's different about them is neon has 4 lone pairs, whereas carbon has 4 bonded pairs where it's sharing. Okay, so they're different in the fact that neon has 4 lone pairs and carbon has 4 bonded pairs that are shared. So in other words, neon actually owns its electrons. These electrons belong only to neon. Carbon is sharing. So really one of the electrons from this bond belongs to carbon, one belongs to hydrogen, but they're sharing the electrons. All right, so that's the difference in, like I said, a lone pair and a bonded pair. So like I said, in my class, you must draw a bonded pair as a dash. I don't want to see 2 dots. I'm super picky about that. Just saying. All right, so let's learn how to write the Lewis dot structure. So I'm going to kind of abbreviate these rules and put them over here so that we can just look at them as we go. All right, so your first step is you need to add the number of valence electrons. So like you'll have a formula, and hopefully you remember how to get valence electrons. I'll just put you a friendly reminder down here in case you forgot. So for valence electrons, remember group 1 has 1, group 2 has 2, group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, 18 has 8, except for helium, which has 2. Okay, so you can just look at what group it's in to figure out how many valence electrons. So number 2, it says bond all the atoms with single bonds. Single atoms go in the middle. So I'm just going to put single bond. Everything. Step 3, add the electrons until each atom has a full octet and each hydrogen has a duet, which is 2 electrons. Okay, so I'm just going to put octet / duet, and after duet, I'm going to put hydrogen because that's the main one that follows the duet rule. And then step 4, add up the total valence electrons in the Lewis dot structure and compare it to the total from step 1. Okay, so we'll just say total valence electrons, and then I'm going to draw an arrow to step 1. So whatever we started with, we have to add at the end. All right, so I know these rules are kind of confusing before you actually try any, so let's look at the first one together. So we have H2. So step 1 says add the valence electrons. Well, hydrogen is in group 1, so it has 1 valence electron. But there's 2 of them, so I'm going to multiply that 1 valence electron by 2. And so H2 has 2 valence electrons total. All right, so all you do is find how many the element has, and if it has a subscript, just multiply it by the subscript. So step 2 says single bond everybody. Well, we have 2 H's, so obviously I really only have the option of kind of arranging it like this. I guess you could put one on top or one on bottom. It doesn't really matter. All right, so we single bonded them. And remember, every time you draw a bond, that is always 2 electrons. Step 3 is follow the octet or duet rule. Well, we're talking about hydrogen here, so we're following the duet rule. So we got to make sure our hydrogens are stable. Well, the bond belongs to both hydrogens because they're sharing. So this hydrogen has 2 electrons, so it's stable. This hydrogen has 2 electrons, so it's stable. So everybody's stable. I don't need to add anything else. So then the last one is add up the total valence electrons and compare it to step 1. Well, I told you a bond is 2 electrons, so I have 2 electrons in my Lewis dot structure. I'm allowed to have 2 electrons, and so that's my structure. Okay, and I'll erase this part because you don't need this part. That's obviously the easiest possible one ever, so that clearly would not be on a test. But we gotta start somewhere. Okay, so let's look at one that's a little bit more difficult. And y'all, the first couple of times you see this, it might be super confusing, so just hold on. I know you'll get it. Okay, they're all super confusing in the beginning. All right, so here we have Cl2. So our first step is add our valence electrons. Well, if you look at the periodic table, Cl is in group 17, so it has 7 valence electrons. But I have 2 of them, so I'm going to multiply it by 2, and so I've got 14 valence electrons that I can put in my structure. Step 2 2 is single bond, everybody. Well, it's just Cl and Cl, so again, this is really my only option on how to bond them. Alright, and then step 3 says follow the octet and duet rule. Well, this was not hydrogen, it's Cl, so it's going to follow the octet rule. So remember, every bond is 2 electrons. So right now, this carbon only has 2 electrons from the bond. Remember, it wants 8 to be stable. That's what octet rule says. So it needs 6 more. So I can put 6 dots around it. So see how now it has 2 from the bond, 4, 6, 8. So now this chlorine is stable. So then we look at our other chlorine. So right now it only has 2 from the bond. It needs to have 8, so it needs 6 more. So I just do 2, 4, 6. And then it has 8 from the bond. Okay, so let me just show you again how it's stable. So remember, every bond is 2 electrons. So this chlorine has 2, 4, 6, 8. This chlorine has 2, 4, 6, 8. And remember, the bond belongs to both of them. Alright, so everybody's stable. So last step is we check our total valence electrons. So I have 2, 4, 6, 8, 10, 12, 14. I'm allowed to have 14, so we're done. Alright, now one thing that confuses a couple of people is sometimes you might think, well, this chlorine has 8 and this one has 8, so isn't it 16? Well, remember, they're sharing the bond. So like when I count 8, I'm technically counting the bond twice, but when you're adding up the total, you only count the bond once. Alright, so hopefully that one wasn't too bad. So let's look at what happens when you have more than just 2 atoms and you have more than the same element, so like H2O. Well, you follow the same steps. So step 1 says add our valence. So hydrogen has 1 valence electron because it's in group 1, but there's 2 of them, so I'm going to multiply it by 2. Oxygen is in group 16, so it has 6 valence electrons. So I have a total of 8 valence electrons to work with for water. Now, this is where it gets a little tricky because it's like, well, what do you do? Like, are we doing like this? Or like some people like try to make some sort of like triangle thing. Okay, when you have more than one element and you have one atom that's single, the single one goes in the middle. So see how there's 2 H's, but there's only 1 O? That means the O goes in the middle. The single atom goes in the middle. All right, so I'm going to put my O in the middle, and then I'm going to bond my H's. Now, eventually when we get to section 8.3, we'll learn that this is not a straight molecule, but we'll learn how to do that later. For now, I just want you to be able to figure out how many bonds and how many dots. All right, so we single bonded everybody. So next is octet and duet rule. Well, hydrogen follows the duet rule. Oxygen's going to follow the octet rule. So let's check our hydrogens first. So remember, it needs 2. Well, every bond is 2. So this hydrogen has 2. This hydrogen has 2. That's the easy thing about hydrogen. It will always have 1 bond, which is 2 electrons. It will never have any extra dots, because once it's bonded, it has 2. It will never have more than 1 bond, because once it's bonded once, it has 2. So like hydrogen couldn't possibly be in the middle, because it can't have a bond on both sides, because that would give it 4. Alright, so hydrogen's stable, so now we've got to look at oxygen. So right now it has 2 from this bond and 2 from this bond, so it has 4. So to get 8, it needs 4 more. So I add those as lone pairs. So see, now if you look, oxygen has 2, 4, 6, 8. Hydrogen has 2, hydrogen has 2. Everybody's stable. So last step is check my total. So I have 2, 4, 6, 8, and I'm allowed to have 8, so I'm done. And in the beginning, it's going to seem like a waste to check your total because it's always going to work out. I'll show you in the next lesson video, part 2, why it's important to check your total. Alright, so let's move on to our last one down here. I'm running out of room, so I'm just going to kind of pull it up here. So it's C2H6. Alright, so when you have C2H something, the way you set it up is you bond the 2 C's and then you split the H's up evenly between the 2. Okay, but let's follow our steps though. So we're going to add our valence. So carbon is in group 14, so it has 4 valence electrons. But I'm going to multiply it by 2 because there's 2 carbons. Hydrogen has 1 valence electron because it's in group 1. But there are 6 of them, so I'm going to multiply that by 6. So in other words, I have 8 plus 6, which is 14 valence electrons. And so like I said, whenever you have C2H something, just bond your 2 C's. So I'll do that first. And then split your H's evenly. So since I have 6 H's, that gives each of them 3. So I'll just do 1 here, 1 here, 1 here. So that carbon got 3. And I'll do 1 here, 1 here, and 1 here. All right, and again, in the beginning, it seems weird to see something like this, but you'll get totally used to it. All right, so we single bonded everybody. So next step is octet and duet. So hydrogen follows the duet rule. So 2 for this one, 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 and 2 for this one. So they're all good to go. Carbon follows the octet rule. Remember, almost all elements follow the octet rule. So this carbon has 2, 4, 6, 8. This carbon has 2, 4, 6, 8. So my carbons are also already stable, so I don't need to add any lone pairs. So last step is check your total. So I have 2, 4, 6, 8, 10, 12, 14, and I'm allowed to have 14. So my structure is correct. All right, so now that you've seen me do some, let's go to the next slide and let you try some on your own. Because you can watch me do these all day long and think you understand, but it doesn't, you can't really understand until you do some on your own. All right, so maybe pause the video, try BR2. I'll assume you've done that, and we'll do it together. So, first step is add our valence electrons. So BR is in group 17, so it has 7 valence electrons. And since there's 2 BR, that gives me a total of 14 valence electrons to work with. Step 2 is single bond, everybody. So I'll do BR and BR. So I single bonded it. Step 3 is follow octet or duet rule. Well, we don't have any hydrogens, so we'll follow the octet rule. So right now, this BR has 2 electrons from the bond. So remember, it wants 8, so it needs 6 more. Right now, this BR has 2 from the bond. It needs 8, so we give it 6 more. Right, so last step is total my valence electrons. So I have 2, 4, 6, 8, 10, 12, 14, and I'm allowed to have 14, so I'm done. All right, so hopefully you got that one right. Okay, so for the next one, before you pause it, okay, I gave you a hint because it has CH2Cl2. The C is going to go in the middle, and then you'll like bond 2 H's to it and 2 Cl's to it. Okay, so try this one, pause the video, and then we'll look at it now because I'll assume you've done that. All right, so first step is we got to add up those valence electrons. So carbon's in group 14, so it has 4 valence electrons. Hydrogen's in group 1, so it has 1, but I'm going to multiply it by 2. Chlorine is in group 17, so it has 7, but I'm going to multiply it by 2. So I have 14 and 4 and 2, so I have 20 valence electrons. All right, so I told you C is going to go in the middle. And so then there's 2 H's and there's 2 Cl's. And it doesn't matter if you put your H's and Cl's where I did, just make sure C's in the middle. And somewhere there's 2 H's bonded to it and somewhere there's 2 Cl's bonded to it. All right, so I single bonded everybody. So see, if I give you a weird one like this, I'll kind of let you know what the setup is going to be. So next we got octet and duet rule. So remember, hydrogen follows the duet rule. So if you look, I have 2 for this hydrogen, 2 for this hydrogen. So hydrogen's stable. And then Cl and C follow the octet rule. So I'll check C. So C has 2, 4, 6, 8. So C's good. Cl only has 2 right now. So remember, it wants 8. So I need to add 6 more electrons. And then this Cl, right now it only has 2, but it wants 8. So I'm going to add 6 more electrons. All right, so last step is check my total. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I'm allowed to have 20. So hopefully you got that one right. That one's a little tricky just because of the fact that it's got different elements bonded to carbon. But remember, that's what I'm trying to show you, is they all work the same way. You just follow the rule. All right, so pause the video and try NH3, and now we'll look at it together. All right, so first we got to add up our valence electrons. So N has 5, because it's in group 15 on the periodic table. H is in group 1, so it has 1, but I'm going to multiply that by 3. So I have a total of 8 valence electrons to work with here. So step 2 is single bond, everybody. So I'm going to put my N, and then I'm going to put my 3 H's. Okay, and y'all don't worry about where they are. Like some of you end up drawing it more like a Y, like you'll kind of do it like this. That's fine. We'll worry about how to do shape in section 8.3. And then you'll know all about shape, and then you'll wish you never learned it, most likely. But because a lot of you think it's really hard. I think it's fun. But anyway, so don't worry about the shape of it right now. What you need to worry about is, are the correct elements bonded, and do you have the right number of bonds and lone pairs? All right, so we single bonded everybody. I put nitrogen in the middle because that's the one that's by itself. So see how it's NH3? So I know the N goes in the middle because there's only one of them. So we got to do octet duet. So hydrogen follows the duet rule. So this one has 2, this one has 2, this one has 2. So all my hydrogens are stable. And then N follows the octet rule. So if you look, N right now has 2, 4, 6. So it needs 2 more to make 8. So now N is stable. And so last step is check my total. So I have 2, 4, 6, 8. And I'm allowed to have 8. And so hopefully you got something similar to that. The most common thing that I see wrong when I come check people's is that they have 1 or more atoms that is not stable. So it either has more than 8 or less than 8, or you accidentally tried to make H follow the octet rule. Okay, so remember there are still 3 more parts to this section. So please make sure you watch these, because what I've shown you in this video are the easiest possible examples. So it definitely gets harder from here.